Hello everyone, this is Abhishek Mahanti and you are watching Padarth Vigyan. So students, welcome to lecture number 3 of the chapter Vectors. In this lecture, we will discuss about the addition of two vectors. Students, we know that vectors are the physical quantities which have both magnitude and direction. And we have discussed that vectors cannot be added like scalar quantities. We know that scalar quantities are added like the way we add two numbers. For example, suppose we want to add two masses 5 kg plus 6 kg, the answer will be 11 kg. But addition of two vectors is different from addition of two scalars. Addition of two vectors does not mean addition of its magnitude only. So while adding two vectors, we have to take into consideration both the magnitude as well as direction. So first we will discuss about how to add two vectors, and then we will discuss about how to add multiple vectors. And remember that there are two different laws to add two vectors. The first one is triangle's law of vector addition. The second one is parallelogram law of vector addition. So today in this lecture we will discuss about the triangle's law of vector addition. So let's get started. So today's topic name is triangle's law of vector addition. So first I will write the statement of this law and then I will try to explain it. So what is the statement? What is the statement of triangle's law? Remember that triangle's law is used to add two vectors. Is that clear? So first let me write the statement of the triangle's law of vector addition. The statement is if two vectors A and B, if two vectors A and B to be added can be represented both in magnitude and direction, both in magnitude and direction by the two sides of a triangle, by the two sides of a triangle taken in same order, then their resultant is represented both in magnitude and direction, by the third side of the triangle, taken in opposite order. So again look at the statement of triangle's law of vector addition. It states that if two vectors A and B to be added can be represented both in magnitude and direction by the two sides of a triangle taken in same order, then their resultant is represented both in magnitude and direction by the third side of the triangle taken in opposite order. So students, suppose we have two vectors A vector and B vector and we want to add the two vectors using the triangle's law of vector addition. Then we know that a vector quantity can be represented by a straight line with an arrowhead. So we will represent the two vectors which are to be added. We want to add vectors A and B. So these two vectors should be represented as the two sides of a triangle taken in same order. So what is the meaning of same order and what is the meaning of opposite order? Let us discuss about that. So we know that every vector quantity can be represented by a straight line with an arrowhead. This one is known as head of the vector and this is known as the tail of the vector. The arrow mark is known as head of the vector and the other end is known as the tail of the vector. So two vectors are said to be in same order if head of one vector is joined to tail of the other vector. This is vector A, this is vector B. If head of vector A is joined or is connected to the tail of vector B, then A vector and B vector are said to be in same order. So same order means head is connected to tail. But if head of one vector is connected to the head of the other vector or the tail of one vector, the tail of one vector is connected to the tail of the other vector, then they are said to be in opposite order. So remember that same order means the head of one vector will be connected to the tail of other vector, and opposite order means head of one vector will be connected to head of the other vector or tail of one vector will be connected to the tail of other vector. So if we want to add vector A with vector B, then I have to represent these two vectors as the two sides of a triangle. A triangle has three sides. Out of the three sides, two sides will represent the two vectors A and B which are to be added. Then their resultant means the sum of the two vectors. A vector plus B vector is the resultant. The resultant is represented both in magnitude and direction by the third side of the triangle taken in opposite order. So since the triangle has three sides, out of the three sides, the two sides will represent the two vectors to be added, and those two sides should be in the same order, and the resultant of that two vectors will be represented by the third side of the triangle, and the third side will be in the opposite order. So this is the statement of the triangle's law of vector addition. Now let us draw the diagram as per this statement. Suppose we have two vectors A and B. This is vector A and this is vector B, and we want to add these two vectors. We want to add these two vectors using the triangle's law of vector addition. So according to this law, the two vectors to be added should be represented as the two sides of a triangle, and they should be taken in the same order. So we know that a vector quantity is specified by its magnitude as well as direction. The length of the line represents the magnitude of the vector and the arrow mark represents the direction. So now I will arrange these two vectors as the two sides of a triangle, and they should be in same order. It means head of vector A will be joined to tail of vector B. Head of vector A will be joined to tail of vector B. So this is vector A, and I will shift this vector so that the tail of vector B will be connected to head of vector A. But remember that when you are shifting vector B, to the head of vector A, remember that don't change the direction of the vector, because if you change the direction, suppose if you slightly rotate the vector and if you place like this, then this is not vector B, because a vector is specified by its magnitude as well as direction. So always keep in mind that when you are shifting the vector B to the head of vector A, you should not change the direction, because when you change the direction of a vector, the vector will be changed. So I will shift this vector B parallel to itself and I will place here like this. Now you can see that vector B is shifted to this new position, but we have not changed its magnitude and direction. The length is same and these two lines are parallel to each other. So without changing the magnitude and direction of vector B, I have shifted it to this end. And what is the reason behind shifting the vector B? The reason is we have to arrange the two vectors as the two sides of the triangle, and they should be in same order. You can see that the head of vector A and the tail of vector B, they are joined. So A vector and B vector are in the same order. So these two vectors represent the two sides of the triangle. Now after arranging the two vectors, their resultant means the sum of A vector and B vector will be represented both in magnitude and direction by the third side of the triangle taken in opposite order. Now let us complete the triangle. So this one is the third side. This one is the third side of the triangle. This is vector B, this is vector A, and this is the third side of the triangle. Is that clear? So this third side of the triangle will represent the vector sum of A and B, or the resultant of A and B. Means this side will represent A vector plus B vector both in magnitude and direction, and the third side should be in opposite order. Opposite order means the head of this vector will be connected to the head of vector B, and the tail of this vector will be connected to the tail of vector A, and this side is known as the resultant vector or R vector. So R vector is equal to A vector plus B vector. R vector is equal to A vector plus B vector. From this diagram you can see that R vector and A vector both are in opposite order, because the tail of R vector and A vector are joined to one point. And again R vector and B vector are also in opposite order, because their heads are connected to one point. Is that clear? So I have drawn the diagram. So this is the geometrical interpretation of the triangle's law statement. So I have drawn this diagram as per the statement. We want to add the two vectors A and B. So we have arranged them as the two sides of a triangle which are in same order. Then the third side of the triangle will represent the resultant of the two vectors, and the third side should be in opposite order with both the vectors. Means R vector, A vector, they are in opposite order. R vector and B vector, they are also in opposite order. Now we will find the expression for the magnitude and direction of vector R, because we know that every vector is specified by its magnitude as well as direction. So if R vector is the resultant of A and B, then we must know what is the magnitude of R vector and what is the direction of R vector. So for that we have to derive a formula. So students, we have these two vectors A and B. Now if I ask you what is the angle between the two vectors, we know that the vectors have different directions, so there must be some angle between the two vectors. Now tell me, if you look at this diagram, if I ask you what is the angle between the two vectors, whether this is the angle between the two vectors or this one is the angle between the two vectors, the answer will be this is the angle between the two vectors, not this one. Because angle between two vectors means the angle between the directions of the two vectors. The angle between the directions of the two vectors. vector A is directed in this direction, vector B is directed in this direction. So the angle between them, if you extend the line up to this point, then this is the angle between the two vectors. So if I will keep the two vectors like this is vector A, this is vector B, then this is the angle between the two vectors, or the angle between the directions of the two vectors. Now in this diagram I have shifted vector B to this end. I have shifted vector B to this end. So the angle between these two vectors will be this one. This angle is equal to this angle. They are corresponding angles. So remember that when two vectors are in same order, you have to consider the outer angle. You have to consider the outer angle as the angle between the two vectors. Is that clear? Suppose assume that the angle between vector A and vector B is theta. So now we will derive the expression for the resultant vector magnitude and its direction, and for that I have to draw an enlarged diagram. I will draw a bigger diagram like this. This is vector A and this is vector B, and we want to add these two vectors. So if I extend, then this is the angle theta between the two vectors, and the third side will represent the resultant vector. So R vector is equal to A vector plus B vector, and this R vector is in opposite order with both A and B. Suppose this is P, Q, this is M, this is the triangle PQM. So in the triangle PQM, the side PQ represents vector A, the side QM represents vector B, and the side PM represents vector R, or the resultant vector. So we have to find the expression for the magnitude and the direction of the resultant vector. So let me draw a perpendicular from the point M onto this line. So if I draw a perpendicular like this angle will be 90 degree, and suppose this is point N, this is point N. Okay, so now look at the triangle in the triangle QNM. In the triangle QNM, look at the triangle QNM. So QNM is a right angle triangle. So in that triangle, sine theta will be how much? This is theta, this is perpendicular, this is base, and this will be hypotenuse. So sine theta is equal to P by H, means Mn divided by Qm. Mn by Qm. P by H is sine theta, and that implies Mn is equal to Qm sine theta. Mn is equal to Qm sine theta. So Qm means the length of the vector. Qm means the length of this vector, and we know that the length of the vector represents its magnitude. So if Qm represents vector B, then the length of Qm will be the magnitude of B. So I will write Mn is equal to B sine theta. In place of Qm, I have written B. Don't give a vector sign, because this length will represent only the magnitude, not the direction. Is that clear? So I have written B. I have not given a vector symbol here. So Mn is equal to B sine theta. Similarly, in the same triangle QNM, find what is cos theta. So cos theta will be B by H, means Qn divided by Qm. That implies Qn is equal to Qm cos theta, and again Qm is B, so Qn is equal to B cos theta. Is that clear? So we have expressed Mn and Qn in terms of this B and the angle theta. Now look at the larger triangle PNM. In triangle PNM, look at the larger right angle triangle PNM. According to Pythagoras theorem, the hypotenuse square is equal to base square plus perpendicular square. Means I can write PM square is equal to PN square plus NM square. PM square. PM is the hypotenuse of this larger right angle triangle. So PM square will be how much? Pn square plus nm square. Okay. So what is PM? PM is the length of this side and the length represents the magnitude of the vector. Since the side PM represents the resultant vector r vector, so the length PM will represent the magnitude of r vector. So in place of PM I can write r. So it will be r square. PM square will be r square. That is equal to Pn square. So Pn can be written as PQ plus Qn. Pn can be written as PQ plus Qn. And here we have to give a square. So in place of Pn square I have written PQ plus Qn whole square plus Nm square. Nm square. So write Nm square. That implies r square is equal to, now let us apply a plus b whole square formula. So this will be equal to pq square plus qn square plus 2 into pq into qn plus nm square. That implies r square is equal to, what is pq? PQ is the length of this side which represents vector A. So the length of PQ will represent the magnitude of vector A. So PQ square means A square plus, what is QN? QN is B cos theta. QN is B cos theta. So here we have QN square. So QN square will be B square cos square theta. B square cos square theta plus 2 into PQ. PQ means A into Qn. Qn means B cos theta plus Nm square. What is Nm? Nm or Mn both are same. So Nm is B sin theta. So Nm square will be B square sin square theta. That implies r square is equal to A square plus B square cos square theta. Now bring this term here, B square sin square theta plus 2ab cos theta. That implies r square is equal to A square plus, here you can take B square common and inside the bracket you will get cos square theta plus sin square theta. And we know that cos square theta plus sin square theta is 1. So B square into 1 will be B square plus this term 2ab cos theta. That implies r equal to square root of A square plus B square plus 2ab cos theta. R equal to square root of A square plus B square plus 2ab cos theta. So students, this is the expression for the magnitude of the resultant vector. Let me write here, this is the expression for the magnitude of the resultant vector. Magnitude of the resultant vector. So you can see that to find the magnitude of resultant vector, we must know what is the angle theta between the two vectors. Suppose there are two forces acting on a body. The first force is 5 Newton, the second force is suppose 10 Newton. We cannot say that the total force or the resultant force acting on the body will be 5 Newton plus 10 Newton is equal to 15 Newton. That is wrong, because when we add two vectors, we must know what is the angle between them. Force is a vector quantity, so when we are adding the two vectors, we must know what is the angle between the two vectors. And after knowing the angle between the two vectors, we can use this formula to find the magnitude of the resultant vector. Is that clear? So this is the way you can derive the expression for the magnitude of the resultant vector. But we know that a vector is represented by the magnitude as well as direction. So we have found the expression for the magnitude. Now we have to find the direction of our vector. Direction means we have to find what is the angle made by the resultant vector with any one vector. So in this diagram you can see that this is vector r, and suppose vector r makes an angle beta with a vector. So if we derive the expression for beta, then we can easily find what is the direction of r vector, because we know the direction of A and the direction of B. So if we can find what is the angle made by resultant vector with vector A, then we can determine the direction of r vector. So now we have to find the angle beta between r vector and A vector. So how to find it? So again, look at this triangle. Look at the triangle PNM. In the triangle PNM, tan beta will be how much? Tan beta will be equal to P by B, means Mn by Pn. Mn by Pn. That is equal to Mn divided by PQ plus Qn. Pn is equal to PQ plus Qn. So tan beta is equal to, what is Mn? Mn is B sin theta. So write B sin theta divided by PQ plus Qn. PQ is A plus Qn is B cos theta. Qn is B cos theta. So write A plus B cos theta. So tan beta is equal to B sin theta by A plus B cos theta. So beta will be how much? Tan inverse B sin theta divided by A plus B cos theta. Is that clear? So in this way you can find the angle between resultant vector and A vector. So what is the meaning of tan inverse? Suppose tan beta is equal to 1 by root 3. Suppose tan beta is equal to 1 by root 3. Then we have to find what is the value of beta. So 1 by root 3, we have to first determine for what angle or for what value of beta tan beta is equal to 1 by root 3. So we know that tan 30 is 1 by root 3. So in place of 1 by root 3 I can write tan 30 degree. So beta will be tan inverse tan 30. So tan inverse tan will cancel, so we will get 30 degree. Is that clear? But sometimes while calculating the value of tan beta, the value of tan beta is such that we don't know the angle beta, because we know the value of tan theta for certain specific angles. For example, you know what is tan 0, what is tan 30, tan 45, tan 60, tan 90, like this. But you cannot say what is the value of tan 65, what is the value of tan 53, what is the value of tan 36. So in that case, what you have to do? So suppose while solving a problem, you get tan beta is equal to x, and you don't know for what angle the value of tan beta will be x. So simply write beta is equal to tan inverse x. For example, suppose you get tan beta is equal to 0.3. Suppose tan beta is equal to 0.3, but in the table given in our book there is no value like 0.3, so we cannot find for what angle beta tan beta will be 0.3. so we cannot use the scientific calculator. So for that purpose simply we can write beta equal to tan inverse 0.3 and you will get the full mark. So students, I have already explained, if we have two vectors A and B and if theta is the angle between them, then how to find the magnitude of the resultant vector and how to find the angle between R vector and A vector. So this is the expression for the magnitude and this is the expression for the angle between R vector and A vector. So now we'll discuss few special cases. So let me write these two formulas on the right side. So the resultant has magnitude R equal to square root of A square plus B square plus 2AB cos theta, and beta is equal to tan inverse B sin theta by A plus B cos theta. So we'll discuss about some special cases. The first case, case 1. If the two vectors are parallel. Suppose the two vectors are parallel. Parallel means what? The two vectors have the same direction. So this is vector A and this is vector B. If two vectors are parallel to each other, then what is the angle between them? The angle will be 0, theta equal to 0. So what will be the expression for the magnitude of resultant? So R is equal to square root of A square plus B square plus 2AB cos 0. In place of theta you can put 0 and we know that cos 0 is 1, so it will be A square plus B square plus 2AB square root. Remember that the maximum value of cos theta is plus 1. So this is nothing but A plus B whole square. So I can write A plus B whole square, then give a square root symbol, that is equal to A plus B. So the resultant vector has magnitude A plus B. Means the magnitude of resultant is equal to the sum of the magnitudes of the two vectors. Is that clear? For example, suppose we have a body and we are applying two forces 5 Newton and 6 Newton in the same direction. Then the resultant force or the net force will be how much? 5 Newton plus 6 Newton equal to 11 Newton. But remember that when you are applying two forces 5 Newton and 6 Newton on a given body, then you will not get this same result at every time, because if I change the angle between the two forces, then the value of the resultant force will change. If they are parallel, if they have same direction, then the net force will be simply the sum of their magnitudes. 5 Newton plus 6 Newton equal to 11 Newton. But if I change the angle between them, suppose the angle is 30 degree or 60 degree or 90 degree, then we will get different values. And remember that the value of cos theta is maximum when the angle is 0. Means the maximum value of cos theta is plus 1. If maximum value of cos theta is plus 1 and it happens when theta is 0, so this is nothing but maximum magnitude of resultant. This is the maximum magnitude of resultant. So R max is equal to A plus B. R max is equal to A plus B. And the resultant vector will also be in the same direction. The resultant vector will also be in the same direction as the two vectors. If you apply the two forces 5 Newton and 6 Newton on this body, then the resultant force will be 11 Newton towards right. Is that clear? So this is the first case. Remember that if A and B are two vectors, then they will give maximum resultant when they are parallel to each other. Now we will talk about case number 2, second case. If A vector and B vector are opposite to each other, or they are anti-parallel. Then in that case, theta will be 180 degree or pi. Is that clear? So in this case, what will be the value of R? R will be equal to square root of A square plus B square plus 2AB cos 180. And cos 180 is minus 1. And remember that the minimum value of cos theta is minus 1. The maximum value is plus 1. The minimum value is minus 1. So I can write A square plus B square. Here we have 2AB into minus 1. That will be minus 2AB. And then give a square root symbol. So A square plus B square minus 2AB is A minus B whole square. Give a square root symbol, that is equal to A minus B. So the two vectors, when they are added, they can also give resultant A minus B. This is the minimum value of the resultant vector. R minimum is equal to A minus B. Is that clear? So suppose this is a body and you are applying two forces, 10 Newton towards right, 6 Newton towards left. So these two forces have opposite direction. So what will be the magnitude of resultant force? The magnitude of resultant force will be 10 Newton minus 6 Newton is equal to 4 Newton. We are adding the two vectors, but we are getting that the magnitude is how much? A minus B, or F1 minus F2. So remember that when you are adding two vectors, their magnitudes can be added, their magnitudes can be subtracted. In this case, the magnitudes of the two vectors are being subtracted. And suppose assume that magnitude of vector A is greater than magnitude of vector B. Suppose assume that magnitude of vector A is greater than magnitude of vector B. Then in this situation, what will be the angle? What will be the angle, or what will be the direction of the resultant vector? The direction of the resultant vector will be along the direction of the larger vector. So out of these two forces, 10 Newton is the larger force, 6 Newton is the smaller force. And if they are opposite to each other, the resultant force will have magnitude 4 Newton and it will be directed along the larger force. Since the larger force is towards right, so the resultant will also be towards right. Is that clear? So if we have two vectors A and B, and they are opposite to each other, the angle is 180 degree, then the resultant vector will be directed along the larger vector. And here we have assumed that vector A has larger magnitude, vector B has smaller magnitude. Is that clear? You can also find the angle between the resultant and vector A from this formula. If you put theta equal to 0, in the first case we have taken theta equal to 0. So if you put theta equal to 0, then you will get tan inverse b into sine 0. b into sine 0. Sine 0 is 0. So b into 0 will be 0. 0 by something is 0. So beta equal to tan inverse 0. Tan inverse 0 is also 0, because we know that tan 0 is equal to 0. So in this way you can find the direction or the angle between the resultant vector and vector A. So we have seen that when the two vectors have the same direction, their magnitudes are added, but when they have opposite direction, their magnitudes are subtracted. And this is the maximum value of the resultant. This is the minimum value of resultant. Is that clear? Now we will talk about the third case. The third case is if the two vectors are perpendicular to each other. Case number 3. If a vector is perpendicular to b vector, then what will happen? Then theta will be equal to 90 degree and cos 90 will be 0. So r is equal to square root of a square plus b square plus 2ab cos 90, and cos 90 is 0, so this term will become 0. So we will get r equal to square root of a square plus b square. So you can see that when I am changing the angle between the two vectors, the value of the resultant is also changing. Is that clear? And what will be the angle beta? In this third case, what will be the angle beta between r vector and a vector? Look at the expression, beta equal to tan inverse b sin theta. So in place of theta I will put 90 degree divided by a plus b cos theta, or a plus b cos 90. So that implies beta equal to tan inverse sin 90 is 1, so b into 1 will be b divided by a plus b cos 90. Cos 90 is 0, so b into 0 will be 0, so we will get tan inverse b by a. So beta is equal to tan inverse b by a. Suppose this is vector A, this is vector B, they are perpendicular to each other. The angle between them is 90 degree. Then this third side will represent resultant, and the angle is beta. The angle between resultant and vector A is beta, and this beta will have value this much, tan inverse b by a. And suppose assume that the two vectors A and B, have the same magnitude. If modulus of A is equal to modulus of B, means they have the same magnitude, means A equal to B, then beta will be how much? Tan inverse B by B, because B and A both are same, so B by B is 1, so tan inverse 1 is how much? For what angle beta? Tan beta will be 1. We know that tan 45 degree is 1. So if we are finding tan inverse 1, then I can write tan inverse tan 45. Tan inverse tan 45. So tan inverse and tan will cancel, you will get 45 degree. It means if I take two vectors having the same magnitude and they are perpendicular to each other, vector A and vector B are perpendicular to each other, then the resultant vector will make angle 45 degree. If this angle is 45 degree, then this angle is also 45 degree. The resultant vector makes 45 degree angle with both the vectors. Is that clear? So these are the three special cases. So we saw that when we are adding two vectors, we must take the angle between them into consideration. and when we change the angle theta between the same two vectors, then what happens? The resultant, the magnitude of resultant changes. Sometimes when they are parallel, the magnitude is a plus b. When they are anti-parallel, the magnitude of resultant is a minus b, and when they are perpendicular, the magnitude is square root of a square plus b square. So from this discussion, we came to know that addition of two vectors is not only the addition of their magnitudes, it also involves the direction, the angle between the two vectors. And remember that when you are adding two vectors, when you are adding the two vectors a and b, when you are adding two vectors a and b, then the maximum value of the resultant will be a plus b, and the minimum value of the resultant will be a minus b. It means this value is obtained when theta equal to 0 degree, and this value is obtained when theta equal to 180 degree. So remember that for any other angle, if you make theta equal to 10 degree, 15 degree, 20 degree, 40 degree, 45 degree like this, then the value of r will also change. But the value of r will lie between a minus b to a plus b. The value of r will lie in between a plus b to a plus b. For example, suppose I have two forces, let us say 10 Newton and 4 Newton. We have two forces 10 Newton and 4 Newton. These are forces vector quantities. So if I ask you which value cannot be the magnitude of resultant of these two forces. Suppose I'll write 3 Newton, then I'll write 7 Newton, I'll write 12 Newton, I'll write 16 Newton. Then out of these four values, which value cannot be the magnitude of resultant of these two forces? So since we have these two forces 10 Newton and 4 Newton, then what will be the maximum value resultant? The maximum value will be 10 plus 4 equal to 40 Newton. And what is the minimum value resultant? A minus b means 10 minus 4 equal to 6 Newton. Is that clear? So the value of resultant cannot be less than 6 Newton and cannot be more than 40 Newton. This is the maximum value, this is the minimum value. So the resultant cannot have any value more than 40 Newton and less than 6 Newton. So look at the first option, it is 3 Newton. So 3 Newton is less than 6 Newton. So this value is not possible because the minimum value of resultant is 6 Newton. You cannot get 3 Newton. And 7 Newton lies between 6 and 14. So yes, this value is possible. 12 Newton also lies between 6 and 14. This is possible. But 16 Newton is greater than the maximum value. This is not possible. So 16 Newton force, this is not possible. So when we are adding the two forces 10 Newton and 4 Newton, the resultant can never become 3 Newton or 16 Newton. So students, today we have finished the triangle's law of vector addition. So hopefully you have understood what is the statement and how to draw the diagram, what is the meaning of same order, opposite order, and how to do the derivation to find the magnitude of resultant, and how to discuss about different the special cases when theta equal to 0 degree, theta equal to 90 degree, theta equal to 180 degree. So in the next class we will discuss about the second law of vector addition, that is known as the parallelogram law of vector addition. So in the next class we will discuss about that. Till then, have a nice day and bye bye.